Hello everyone, let us start with our question. In this question, what is given? Charge Q, 2Q and 4Q are uniformly distributed in three dielectric solid sphere 1, 2, 3 of radius r by 2, r and 2r respectively as shown in the figure. Now, if magnitude of the electric field at point P at a distance r from the center of the sphere is given as to be E1, E2 and E3, we need to find the correct order of magnitude. Okay, so first of all, we find the value of the electric field E1. Okay, so for E1, for E1, P is outside this sphere. Okay, so this would be behaving just as a point charge. So we can say that electric field would be equals to 1 by 4 pi epsilon, and the charge is Q divided by what is the distance from here to here? It is r. So it would be r square. Now E2 value we calculate. So it is again on the surface of the sphere. So we can just treat it to be a point charge. We can just write the value as 1 by 4 pi epsilon, and the charge is 2q divided by distance is r square. Okay, now for the third case, so it is lying inside the charge for inside this sphere. So we can say that our E3 would be whenever a charge is lying inside the sphere. So E3 is given in terms of the this charge density rho as rho r divided by 3 epsilon. Now where rho is the volume charge density, r is the radial location, which in this case is capital R. So we put the value of rho. Rho is what? Rho is the volume charge density. So volume charge density means what is the total charge? Total charge divided by volume. Total charge is 4q. 4q divided by volume would be what? Volume would be 4 by 3 pi into r cube. Radius is 2r, so 2r cube into this. What is the radial location at which we need to find the electric field? It is r divided by 3 epsilon. Now if we solve this, then our E3 value would turn out to be 1 by 4 pi epsilon. Okay, it would be q divided by 2 r square. So here itself we write the value of E2 which we have got. E2 value turns out to be 1 by 4 pi epsilon 2q divided by r square, and our E1 value turns out to be, E1 value was 1 by 4 pi epsilon then q divided by r square. Now if we check this, okay, which would be the correct order of relation? So maximum value would be what? Maximum value would be our E2. So we say that our E2 would be greater then which comes? So it would be E1, and then what would be coming? It would be E3. So this is the order. So E2 then 1 then 3. So which is the correct option for our case? So E2 then E1 then E3. C is the correct option. Hope you understood the solution. Thank you.
Hello everyone. In this question, two charges each equals to q are kept at x equals to minus a and x equals to a. Right. So the two charges are of same sign. You can see a particle of mass m and charge q naught is placed at origin. Now if charge q naught is given a small displacement, right? So keep this small term in mind. Now along y-axis, so net force acting on the particle will be proportional to. So let us draw the diagram first. One charge is kept at x equals to a is this. Another charge is kept at x equals to minus a is this. And let's suppose I displace the q naught like this, right? This is the y, and you can see the two charges. By the two charges, it will get a force like this, F, and this angle will be theta and theta. So the resultant will be in this direction, and the resultant will be 2f cos theta. Since the sine component will get cancelled out, f sine theta and this f sine theta will get completely cancelled out, right? So I will write as 2f cos theta is the net resultant force, right? So what is cos theta here, right? So let us find out the cos theta and force now. So this is the resultant force expression we got after solving this, right? So here the F is equals to, yeah, so we can calculate the F by K q naught by r square, where r is the distance. So you can see the r square is equals to a square plus y square, right? So I will write it as k q naught by a square plus y square. Now it's turn to write cos theta. So you can see already if this angle is theta, right? If this angle is theta, you can, if you draw a bigger diagram, so you can see if this angle is theta, then this angle will also be theta, right? So you can write the cos theta here. This is y, this is a, and this is a square plus y square under root. So I will write cos theta is equals to y by under root this. So just put these two values in the this expression, right? It will be k q naught by this, right, into y by under root of a square plus y square. So finally you will get the expression of fr as k q naught by a this into y. Now, yeah, there is a 3 by 2 power also. Now the y is very less than a, right? So this y can be ignored. So the force Fr is simply directly proportional to y. So D is the correct answer, right? Simple, clear. So the force here, the resultant force will be proportional to the displacement from the x-axis. So the charge which is displaced here may perform the simple harmonic motion for small displacement also, right? Thank you.
In this problem, we have given that 6 charges of equal magnitude, 3 positive and 3 negative, are to be placed on PQRSTU corners of a regular hexagon such that the field at the center means O, okay, is double that of what it would have been if only one positive charge is placed at R. Which of the following arrangement of the charge is possible for P, Q, R, S, T and U respectively? Okay, so we have given that to find the electric field at the center, and there is only one positive charge, and consider the magnitude of charge is Q. Okay, so we know that electric field can be given as kq upon r square, and from all the corners the distance of the corner to the center is same and magnitude of the charge is same, so electric field will be considered as E. Okay, so say the electric field at the center is E. Now let's talk about the direction. So due to positive charge, the electric field always acts away from the positive charge, so the direction of electric field at the center will be in this direction. So in this case we can see that at the center of the electric field, the direction of electric field is this and magnitude is E. Okay, now let's talk about the options given here. Okay, so we have given 4 options over here. So let's start to arrange the charges and find that O, the net electric field is 2E, because it is given that this would be double of the initial. So starting from P, so this is positive charge. Okay, option A, according to option A, Q is also positive, R is also positive, S negative, T negative, U negative. So we can see that due to positive charge at P, the electric field will be in this direction, say E. Due to Q, the electric field will be in this direction, say E. Due to R, the electric field will be in this direction, and consider this is also E. Due to S, this is negative charge, so electric field will be attractive, and this is E. Due to T, the electric field will be attractive because charge is negative E, and due to U, the electric field is attractive, this is also E. So we can see that at O the electric field is 2E in this direction, 2E in this direction, and 2E in this direction. So the equivalent of E equivalent at O is not equals to 2 times of E. So we can say that option A is wrong. Now again we are going to arrange the charges according to option B. So let's talk about option B. So in option B, at P there is charge negative, Q is positive, R is positive, and R is positive, S is also positive, T is negative, and U is negative. So due to negative charge at P, electric field will be in this direction. Due to Q, the electric field will be in this direction. due to R the electric field will be in this direction, due to S the electric field will be in this direction, due to T the electric field will be in this direction, okay, and due to U the electric field will be in this direction. And obviously at O this is not equals to net electric field, that is 2E, so this option will also be wrong. Now let's talk about option C. So again we have option C, that is negative charge at P, positive charge at Q, then positive charge at R, negative charge at S, positive charge at T, and negative charge at U. So due to negative charge at P, the electric field will be in this direction. Due to positive charge at Q, the electric field will be in this direction. Positive charge at R, the electric field will be in this direction. Negative charge at S, the electric field will be in this direction. Positive charge at T, the electric field will be in this direction, and negative charge at U, the electric field will be in this direction. So we can say that this E will cancel this E because they are opposite in direction. This E will cancel this E because they are in opposite direction. So at O the net electric field will be existing in this direction, and that is equals to E plus E, that is 2E. So we can say that in this condition the electric field at the center is 2E, which is double of the former. So we can say that option C is correct. Okay, now let's talk about option D also. So if we are talking about option D, so we have given at P the charge is positive, Q is negative, R is positive, S is negative, T is positive, and U is negative. So due to positive at P the electric field will be in this direction, negative at Q the electric field will be in this direction, positive at R the electric field will be in this direction, positive at T the electric field in this direction, negative at S electric field in this direction, and negative at U the electric field in this direction. Now in this case we can see that this is also not equals to 2E, so we can say that the option D is also the wrong answer. So only option C is the correct for this problem. Thank you.
Hello students, our question is an electron of mass me initially at rest moves through a certain distance in a uniform electric field in time t1. A proton of mass mp also initially at rest takes time t2 to move through an equal distance in this uniform electric field. Neglecting the effect of gravity, the ratio of t2 by t1 is nearly equal to. The solution for this is electrostatic force E will be equals to E into E for both particles. Okay, E will be E into E for both particles, but acceleration of electron and acceleration of proton will be different from each other. So acceleration of electron AE will be equals to FE upon ME. Okay, FE upon ME, and acceleration of proton will be equals to FE upon MP. Okay, so if we find S will be equals to half AE into T1 square. Okay, and S will also be equal to half AP T2 square. Okay, so S is equals to half AE. These both are equal, so it can also be equal half AE T1 square will be equals to half AP T2 square. Okay, so half will get cancelled out, and T1 upon T2 will be equals to T1 upon T2. So we have to find the ratio of T2 upon T1, sorry, T2 upon T1. So T2 upon T1 whole square will be equals to AE upon AP. Okay, and we know the value of AE and AP. So T1 upon T2 whole square will be equals to AE is FE upon ME whole upon FE upon MP. So FE will get cancelled out. Okay, 1 upon 1 upon. So sorry, it is T2 upon T1. T2 upon T1. So from here we can clearly find out the ratio of T2 upon T1 will be equal to whole under root MP upon ME, and this is our answer. So in options it is whole under root MP upon ME. This is our answer.